All right, and we are here for session number 3 for this evening, session number 9 in total of ANZ Coders. Daniel Marbach, I don't know if I've just butchered your name, sorry, Daniel. What am I doing? Transactions and Async Await. I'm not doing anything. Daniel's doing it all. I'm just going to sit back and wonder what the medication I'm taking is doing to my head. Daniel, I'm going to mute myself, disappear. It's over to you to enjoy yourself with the audience, so to speak, and it's all yours.
Cool, thanks, Richard. Hi, my name is Daniel Marbach, correctly spelled out and pronounced. I'm the CEO of Tracelight GmbH in Switzerland, and I'm also working as a solutions architect for particular software, the folks behind ANZ Bus. As you can see presenting on my screen, I think I'm the only one who is going all in with code, so let's have the fingers crossed that this all works out. I'm executing this test here. So by the way, disclaimer first, if you're attending this presentation to learn something about Entity Framework, then please shut down your computer and go to bed, because this presentation is not about Entity Framework. It's more a deep dive into the curiosities of the transaction scope in combination with Async and Await. And I'm pretty sure you will learn a lot of unnecessary stuff during this presentation, which makes you the king storyteller in your local geek bar. So let's get started with some actual stuff. So let's do a brief refresh on the transaction scope. The .NET platform has under the namespace system.transactions a very nifty class called transaction scope. The transaction scope itself allows you to wrap your database code or your infrastructure code, and sometimes even your third-party code, if supported by the third-party library, inside a transaction, and only perform the actions when you actually want to commit or complete the transaction. As long as all the code is inside the transaction scope and on the same thread, all the code on the call stack can participate within that transaction scope. By wrapping your code with a transaction scope, you're using an implicit or also called ambient transaction model. The benefits, but also sometimes drawback, depending how you want to see it, of the transaction scope is that the local transactions automatically escalate to a distributed transaction if necessary. The scope, but the scope itself simplifies the programming with transactions if you favor an implicit over an explicit model. There are a few important caveats you need to consider when you work with transaction scope. So one is it has a limited usefulness in cloud scenarios because the cloud doesn't support distributed transactions. Yeah, we finally got rid of that DTC beast in the cloud, luckily. And it only works with Async and Await with the .NET Framework 4.5.1. Let's take a look at an example how you use the transaction scope normally. So we have this sample here. We have outside the transaction scope, the transaction.current property provided by systems transaction object is actually null. If you open the transaction scope, then inside the transaction scope, the transaction.current is not null. So it's set to the ambient transaction provided by the transaction scope. And if we have a method in the call stack, also that method has the transaction.current set to not null. And as soon as the transaction scope completes, the transaction.current is null again. Let me prove that to you by executing that piece of code. So as you can see, the whole test is green. Transaction scope, intro or refresh, this test here. So this actually works. So when Async and Await was introduced with .NET 4.5 and C# 5.0, Microsoft completely forgot a tiny little detail. The state machine introduced with Async Await, done by the compiler, didn't properly float the transactions around when an async method was called under a wrapping transaction scope. So in order to make the transaction scope and async work properly, you need to upgrade to .NET 4.5.1. But let me briefly show you what went wrong. So this is the example. We are doing the same as before. We have a transaction scope. The transaction.current is null outside the transaction scope. It is not null inside the transaction scope. And then we have a method in the call stack, which is awaited. Let's dive into that method. The method does nothing more than an await of task delay. It awaits 500 milliseconds. And then we assume that transaction.current should not be null, right? Yeah, we will see that this is not the case. So let's go back to my test. Sorry for the scrolling. So let's execute the test and see what happens. As you can see, I already annotated my test with expected exception. So I'm commenting that out. I'm running the test here on my machine. So what we can see is an invalid operation exception is thrown. The text says a transaction scope must be disposed on the same thread that it was created. So, okay, apparently transaction scope doesn't really work with .NET 4.5 because when this continuation is executed, the transaction complete and also the dispose is executed on a different thread, and therefore not on the calling thread, and therefore this exception is raised. What can we do with .NET 4.5.1? With .NET 4.5.1, they have introduced a constructor overload, which takes in an enum, which is called transaction scope async flow option .enabled. This enum tells the underlying .NET runtime that the transaction flow across thread continuations should be enabled. And then the whole infrastructure actually works. By the way, there is also a suppress enum value, which is the default value, of course, because Microsoft couldn't introduce breaking changes between .NET 4.5 and .NET 4.5.1. So if we specify that specific enum enabled, then the underlying state machine is actually created correctly, and the continuation happens on the right on the calling thread. And let's execute that test as well. So this time we shouldn't see an invalid operation exception. So right, everything works. But that's not all, because we're talking about the secrets of transaction and transaction scope. So let's dive deeper in the whole abyss of transactions and transaction scope with Async Await. So let's assume, just for the sake of this presentation, we are building our own NoSQL database. I'm sure all our attendees here, they wouldn't do that, because never ever do that unless you really know what you're doing. But for the sake of this presentation, let's assume we're building such a NoSQL database. The idea of that database is that we want to store objects in memory, and as soon as we call SafeAsync, we want to write all the underlying stored objects into the underlying storage. What I'm doing here is I'm storing 10 Swiss guys into the database. I'll briefly show you what I'm doing. It's not doing more than just calling database store, adding 10 Daniels. So Daniel 0 until Daniel 9. So these are the 10 Swiss guys we are storing in the database. Sorry, I need to scroll back again. That's the downside of showing code. So here we are. So, okay, let us briefly explore the code behind the scenes, what we are doing. So let's dive into the SafeAsync method. In that case, we talked about ambient transactions. So I'm accessing transaction.current. In case there is no ambient transaction surrounding that SafeAsync method, this transaction.current property is actually null. So for the first part, when we are exploring the code, we assume that we are always in this if statement here. So we're calling save internal async. When we call save internal async, we're doing nothing really fancy. I'm for eaching over the stored object, which is in a list of objects, and then I'm opening up a stream, doing some JSON serialization, flush the stream, rewind the position, and then I asynchronously store that stream into the underlying storage. That's what I'm doing here. It's also nothing fancy. I'm copying that content of the stream in an asynchronous manner into a already opened file stream, and then I flush that file stream. Of course, that NoSQL database implementation I just did, this is nothing you should actually use in production, so please be aware of that. I'm just saying it. So, and in the case of the dangerous modes, the database has 3 modes. I'm going to explore those more in short. In case of the database mode dangerous, we are throwing a directory not found exception directly in this save internal async method. So let's go back to our test and see what happens. Let's execute the synchronous mode first. So we are executing this test. Everything is green, and we just wrote a text file to the database, which looks like this. So we have now 10 customers in our, or 10 Swiss guys in our little database. So far, so good. Okay, so now let's see what happens when we are using the dangerous mode. I'm going back to my script. I'm commenting out this one. I'm using the dangerous mode here. And remember, I'm throwing an exception in the first iteration. So what we should see, if everything works fine with Async Await, we should actually see the exception bubbling up to the caller. And therefore, this unit test should be failing. So let's execute it. And we see the directory not found exception, which was raised in our save internal async method. So cool. Now let's assume we shipped our database, all customers are happy, and we have a few customers approaching us and saying, we want to have transaction scope support with that NoSQL database. So how can we do that? So how can we leverage the ambient transaction model in our NoSQL database? I quickly show you what I want to achieve. What I want to achieve is I want to have a SafeAsync inside the transaction scope with this, of course, transaction scope async flow option enabled. And if we complete the transaction, then everything should be written to the store. And in the other case, if we roll back the transaction, so therefore, if we don't complete the scope, then nothing should be written to the store. So let's go back to the complete method. How can we achieve that with .NET? This is actually fairly simple in quotations. We need to write a so-called e-enlistment notification implementation, which we need to enlist volatile. I'm showing you that. So the .NET runtime has a so-called e-enlistment notification interface, which has a bunch of methods called prepare, commit, rollback, in doubt, and so on. I'm defining a base class in order to not override all methods again, because what I'm showing you guys here is I'm only doing stuff in the commit phase. We could argue the whole day along whether it makes sense to do it in the commit phase or whether we should do it in the prepare phase. I'm not diving into that now because I think it would. This is another talk for another ANZ coder sessions. So let's see what we can do. And by the way, I'm also not going to talk about resource managers, multi-phase and single-phase commits, because I think this would make a lot of heads exploding around the globe. So let's put that aside as well. Okay. So how would synchronous, or how do we plug that into our database? Let's go back. The SafeAsync method. In the case we have an async, we have a transaction surrounding the SafeAsync, that code doesn't apply. So we need to somehow delegate the save under transaction async to a function delegate. I'm preparing that function delegate here. So what I'm doing is, as said, I'm enlisting on the current transaction in a volatile manner Volatile means we cannot recover from failures in case when something unforeseen happened on the resource manager. So I'm enlisting an implementation of this iEnlistment notification interface, which calls or does not call the safe internal async method. In order to comply to the interface of this delegate, which is returning a task, I need to wrap that in a task from result. So this is an already executed or already finished task. I'm wrapping this call in. This is a kind of nifty trickery you can pull off. So let's see the synchronous resource manager, how it works. So it gets in a func of task, which is called operation, which points to the safe internal async method in our case, and then it does an operation dot wait. So it's actually blocking that task and waiting until it's completed. So let's see how this works. I'm commenting out the dangerous and async mode. So I'm executing this complete test. I'm executing it, and it's green. And we have now on our storage, we have now a file containing 9 customers or 9 Swiss guys. Awesome, that worked. So I think we can go home. Everything is fine. No, it isn't. The problem is we are violating now the best practices of async and await called async all the way. Async all the way means that you shouldn't mix synchronous and asynchronous code without carefully considering the consequences. So it's particularly a bad idea to block on async code by calling task wait, which we are doing here, or task.result. You risk running into deadlocks. Please do me the favor and Google the question, why does my partially async code deadlock? This is by far the most asked question on Stack Overflow and other question portals. So the root cause of this deadlock is due to the way how await handles contexts. By default, when an incomplete task is awaited, the current synchronization context is captured and used to resume the method when the task completes. So the current synchronization context, for example, in a console application, points to the current task scheduler. In a Windows Forms WPF application, it points to the synchronization context of Windows Forms or WPF. But here, when the await completes, so it attempts to execute the reminder of the async method with that captured context. But the problem is that context has already a thread in it, which is synchronously waiting for the async method to complete. So they deadlock each other. So therefore, this approach, it works, but it is really brittle to strange behaviors or even deadlocks. And I don't want to run into those issues during production. So what can we do else in order to resolve that issue? We can do a simple trick. Let's see. We can use the dangerous resource manager. As you can say by the name, it's dangerous, but let's explore it. We pass in a func of task, it's an operation, and we await that operation. Because we await that operation, the compiler it is really friendly and tells us that we need to mark that commit method async void. Awesome, that works. Cool. So let's try it out. So I'm executing the test. Give me a second. So I'm executing the test. Test is green. Awesome, it works. But let's see what arrived on the underlying storage. Let's open it. So the underlying storage didn't receive any Swiss guy. Oh, that's terrible. So we just lost 10 important Swiss guys. They haven't been written to our database. That's really evil. And I think we don't want to run into those situations in production. So the general rule of thumb is avoid async void whenever possible, except when you are in event handlers. So by making the resource manager commit async void, we completely lost control in case of exceptions. So if the safe internal async method throws an exception, like we are simulating here, when we are running under the when we are running under the dangerous mode, then we never get that exception bubbling up to the calling thread. So therefore, we are never noticed that something happened. That exception is actually raised behind the scenes on the current synchronization context, or in the case when there is no synchronization context set on the current task scheduler. So we saw that blocking isn't really an option. So wait isn't really an option, and async await with async void is also not really an option. So what else can we do? We can introduce a so-called asynchronous blocking way. That sounds really strange, but let's explore it. So we have again that resource manager. It gets in an func of task, an operation, and then we pass that on. You see, we didn't change the method to async void or anything, so we pass that on to an async pump run method. What does it do? This is what I would call Stephen Taub magic by the PFX team. So let's see what it does. It captures the current synchronization context. So in the case of a UI thread, or this is actually the synchronization context of the UI thread. Then it creates a so-called single-threaded synchronization context. It sets that synchronization context. Then it invokes the func of task, and it adds a continuation which completes that synchronization context on the default task scheduler. Then it pumps the whole synchronization pump context, and then it calls of that specific task the awaiter and gets the result. So in the case, if anything happened in the background, that task goes to the faulted state, and the exception is then raised back to the caller thread. And in the end, in the final block, we're actually setting the previous synchronization context back in order to be correctly back again on the correct synchronization context. This single-threaded synchronization context is nothing really fancy. It uses a blocking collection behind the scenes, which gets all the posts of the synchronization context and adds them to this blocking collection. And the complete method marks that blocking collection as completed adding, and the run current thread just iterates over that consuming enumerable. So that method actually here blocks until complete adding is called, and when complete adding is called, we execute all those send or post callbacks which were scheduled or posted on our synchronization context. That's all the magic. So let's go back into our script or PowerPoint slides, however you want to call it, and see what this changes. So we are now using the async blocking mode, and let's execute that test again. In that case, everything was successful. I'm opening up the underlying storage. Even in that case, it was written to the disk, but I think you don't believe me that this is working, because so I'm now introducing in the database another error condition. So let's say we also say when the mode is async blocking, then we also throw a directory not found exception. So if everything works fine, we just did, we should now see the exception bubbling up even in the async blocking mode to the calling thread, therefore the unit testing thread. So let's execute it. I'm executing it, and as we can see, we now see the directory not found exception correctly marshaled to the calling thread and therefore the unit test. So far, so good. By the way, I'm calling this mode async blocking mode. Seems controversial No, it's not. It is a blocking operation. So run on current thread, it's blocking. So what happens, this one here is slightly better. So when we're using this async pump, it's slightly better than doing wait. And of course, it doesn't have that drawback of deadlocking because we're correctly handling synchronization context and all, but it blocks. So when the transaction scope.complete call is issued by a calling thread, this one here is blocking. We could, of course, tweak this implementation of the async pump to, for example, get an IEnumerable of func of tasks and then do a when all, for example, on all these enumerable of tasks, but this would only improve the performance slightly of the resource usage. So we didn't gain much when we used that async pump. So in retrospective, we can say because we are still blocking here, and therefore we are also, when you look at the script, we are blocking the calling thread when we complete the transaction scope, we actually lose almost all the benefits of async and await when we do that. So in retrospective, what we just learned is AsyncAwait is really evil, so use it carefully. When we use AsyncAwait, then use async all the way. And in a cloud first and async world, no pun intended, try to avoid the transaction scope as much as possible. And modern frameworks like Entity Framework 6 and higher, for example, Entity Framework 7, they support their own transaction implementation, and you should use those in your code and not rely on transaction scope. If you really need to support transaction scope, for example, if you have a third-party, if you write a third-party library, an open source project or anything like that, then you should use the async pump and enlist your own stuff with that async pump. And last but not least, if you write an async-enabled library, then configure await false is your friend. So let me end this presentation with a little giveaway I have prepared for the community. It's worth thousands of dollars, as you can see in this presentation. So I'm opening up the slide. By the way, this is provided by particular software, the guys I'm working for, the guys behind nService Bus. You guys from the community, you all get access to the famous Advanced Distributed Systems Design course of Udi de Haan. So if you're a team lead, an application or solutions architect, as well as a technologist, I think, and if you are involved in decision processes and you want to learn something about distributed systems, and this course covers everything like temporal coupling, spatial coupling, messaging, broker architectures, and stuff like that, then I'll advise you to get access to this course. It's the first 2 days of the 5 days Advanced Distributed Systems Design course. By the way, this course expiration date is on the 9th June, so access the course until then. If you haven't managed to write it down, you can always rewind the recording on YouTube and get the access code again. So this is the giveaway from particular software to the ANZ coders community. And let me finish with all the stuff. The code I just showed you, if it was too fast, don't worry. It's all up on my GitHub account under Daniel Marbach /async transactions. There is even a transcript describing everything I talked about here in that presentation in a written form, in case you didn't manage to understand my bad English. So it's all written down, and a few links, and this is also written into a markdown file in the README on that GitHub account. So I think that's it for today, Richard.
I'm still processing.
Okay.
That's cool. There was few people in the chat. I don't know if they've set their video settings to high res or not, or if they're just struggling with bandwidth. But the giveaway, what's the URL? If you can just type that into the chat window.
Of course I can. Give me a second.
Oh, wait a second. Look at that. Alexi's already jumped in and done it for us. Fantastic.
Ah, okay. And also the access code?
How good's that?
You need the access code.
Got that.
Where's the chat window? Here it is. Here we go.
Fantastic. Fantastic. Okay, let's see if we've got any questions. No, not yet. My question. What is my question? Thank you, Bilal. That's awesome.
I'll skip. My head just exploded. Okay. So apparently they like the code, right?
Oh yeah.
Okay.
Yeah. I think Robert summed it up first. It needs to soak in first. I think this is one of those areas people just kind of assume everything works, and then you've just shown everyone that, you know, behind the scenes it's ugly.
Yes, it is. Especially there, you hit a lot of edge cases in the .NET runtime.
Awesome. Thank you, David. All right, so what we might do then, in terms of your trick to have a good sleep after such a presentation is alcohol.
Absolutely. For me, it's the middle of the day, so I'm not sure I can drink beer, but.
So what we'll do is we will call it thank you for the evening. Thank you for that session. That was awesome. Guys, do the usual applause in the chat window. I think you're getting the feel for the session in the chat window there. And we will call this it for the video part of the evening. I'm assuming Daniel will hang around and chat in the chat window just for a few more minutes, and then we'll all disappear and you can go back to work, Daniel, and we'll do some sleeping and things like that. Just in terms of tomorrow, very quickly, what we've got is, and I had it handy and then closed the window because I was so organized. So we've got some tips and tricks for .NET kicking the evening off, and then we're doing Sitefinity, CMS, and then Kanye is coming in again to talk about working distributed. So apparently pants free. I'm hoping that he stays, you know, chest only in terms of the video part and doesn't stand up, because that's going to be no good at all. About, you know, working distributed teams and probably talking from his experience at GitHub. So that will be good as well. So we will see you tomorrow night. Thank you, everyone. Thank you again, Daniel, and the other presenters for this evening. So Poya and Philip, thank you guys. And we will see everyone tomorrow. And we're done.
Have a great evening.
Thanks.
Bye-bye for Switzerland. See ya.